So I found that a few students have difficulties with converting exponentials to logs and back, and we're going to go through this because you need it to draw graphs. So I'll start off with a question, say 3 times 5 to the x equals 75. So what you can do here is you want to find x. Your answer's going to be down here. And the question is find x. So you're going to want an answer like this. So all you need to do is just think about everything in the way and get rid of it. So the first thing we want to get rid of this is the 3. That's the easiest one to get rid of. Equals 75 on 3 equals 25. Now from here, what you can do is log 5 of both sides, because you want to get rid of this 5. So 5 to the power of something. So to get rid of it, you just go log 5 of that. And everything disappears, so I'm just going to write log 5, 5 to the x equals log 5, 25. Not hard yet. All I did was took this and put it inside. Now when we log 5 and the 5 to the power of x, they actually cancel each other out. And what actually happens is, I'll write it down again. Everything cancels out here and the x comes down. So it just becomes x equals log 5 of 25. And now we can say 5 to the power of what equals 25. 5 to the power of 2 equals 25. So x equals 2. And that's how we get to our answer. So let's try another one. Let's do 2 times 3 power of x equals 54. Okay. So again, what we do first is we get the 2 over. So we get 3 to the x equals 27. And now we want to get rid of this 3 to the power of something, so we log 3 it. And now that just all cancels out and the x just comes down, so that equals x. Okay? In fact, we don't even need this step. I could just go log 3 of this, the x just comes straight down. But then we have to log 3 the other side as well. So therefore we can ask now 3 to the power of what equals 27, 3 to the power of 3 equals 27, and x equals 3. So it's not that hard. So I'll let you try this one. 3 times 2 to the power of x equals 54. So first step is remove as much as you can. Remove as much as you can. So maybe I'll add a few extra things actually. Let's make that plus 5, and let's make this 59. So what we need to do is remove the 5 first, so we get 54, and then we can divide by 3 to get, what's that divided by 3? I think it's 16, yeah, 16. Okay, now we want to get rid of this 2 to the power, we want to get rid of this power of 2. So we just go log 2 of both sides, because we're trying to get rid of that. And then we just get straight to x equals log 2 of 16. And 2 to the power of what equals 16? 4. X equals 4. Okay. So that's getting from an exponential to no exponential. To getting a log. So I'll show you how to get rid of logs now. And logs are quite easy too. We have log 2, 5 equals, let's say, y. Never mind that. Let's make this x. I'm going to remove all of this. Log 2 of x equals, let's say, 10. Okay. So, let's say I want to figure out what x is. What we do is just, to get rid of 2, we do the opposite. So we power both sides by 2. You know, 2 to the, if we have this, we can just write 2 at the bottom. 2 to the power of log 2x equals 2 to the power of 10. And just like before, now they cancel out and the x comes down. X equals 2 to the 10. So, I have 1. Log 2 of, so let's make it 3 this time. 2x plus 5 equals 11. I want to get rid of the 3, log 3, so we just go 3 to the power of both sides, and then that cancels out. You know, the entire 3, log 3 cancels out, and we just get 2x plus 5 equals 3 to the power of 11, because we need to power both sides. And therefore 2x equals 3 to the 11 minus 5. X equals 3 to the 11 minus 5 on 2. Maybe I'll give one more example before I head off. Let's try log 3 of y minus 1 equals 2. So let's do one where we can actually get an answer. That's not too huge. We want to get rid of the log 3. So we got 3 to the power of both sides. Cancels out. 3 to the power of 2. That equals 9. Y minus 1 equals 9, so y equals 10. And that's how you go backwards and forwards. It's just a very simple way to convert exponentials to logs and back. Okay, we'll go on to graphs next, promise.